So this was a similar problem to homework 8, maybe question 9. And there was a capacitor that's charged. In there, I do say that there is a leakage current, resistance. But here it's a trickier problem. There's a 100 millifarad capacitor, which is 0.1, and it's charged to 5 volts and then left on a desk. Basically, as soon as you charge a capacitor and you don't touch it, it is following an exponential decrease. So the voltage across the capacitor will be the voltage across the capacitor at 0 times an exponential to the minus t over tau volts. And here I'm saying it's 5 volts. So e to the minus t over tau, Vc of t. So we know this is what's happening to the capacitor because and tau is RC. Because we're not doing anything to it. There's no other voltage applied until the end of time. In principle, you're just putting the capacitor there on the desk. And so what happens is there is that capacitor and there is a resistor there. Chances are the capacitor is slowly discharging. And this slowly, it turns out, is 24 hours. And I wrote here 24 hours is 86,400 seconds. And what happens is after that time, it has 1.8 volts. So Vc of 86,400 is 1.8 volts, which is 5e to the minus that time t over tau. And it turns out 1.8 volts is sort of 64% less than 5. So I have this strong feeling that it is when t equals tau, then the voltage across the capacitor at that time, at tau, will be 1.8 volts. Actually, I think to solve the other problem, to solve the problem of homework 8, you do need to, you have tau, and what you want is to put that voltage here that they give. Let's say they ask you, when does it go to 1 volt? You put here, 1 equals 5, e to the minus t over tau, and you have tau. Here the catch is, we want tau. So tau is 86,400, and that's R times C. So we know that the resistance will be 86,400 divided by C, which is 100 milli. And 100 milli really is 0.1. So it's really this multiplied by, I don't know if you can see it. It's really multiplied by 10, 864 kilo ohms. So what happened? The leakage resistance of 860K is discharging the capacitor. I hope this makes sense. Actually, maybe 5 times e to the 1, e to the minus 1 is 5 divided by e, which is more or less 1.8 volts. I think this is the only thing that may be not very clear that I used without really, being fair. But I only remember actually 10 volts, and I remember 3.6 volts. So it takes tau to go, it takes RC seconds to go from 10 volts to 3.6 volts, to lose 64% of the voltage or of the power. So that's the idea of a time constant. I hope this helps. If this doesn't help you solve the homework 8 question 9, please let me know and I'll post a video that's a little bit closer to that question.